Welcome to Heart of Mathematics. This is an introduction to dimensions. So when you were in geometry, you might have learned about the idea of dimensions. So let's start and just get an idea. So when we talk about a zero-dimensional object, you might think about something that has 0 dimensions, and you're like, what is this? A zero-dimensional object is something where you have essentially no freedom. And so a zero-dimensional object is defined to be a point in space. And so a point in space, when we think about it, if it's just a point, there's nowhere this point can go. If we're on this point, there's no direction in which we can move. Versus if we have a one-dimensional object, we can move in several points, in either direct forward or backwards. And this would be like a line. So a line in space. So if I can start on a particular area here, if I start in one spot, I can move in one dimension. I can either move forward or backwards. So we say this has one dimension. Continuing the idea, we have a two-dimensional object. This would be like a plane in space. So we would have like a square, right? So given a point on the plane, I can describe it moving in kind of like the X direction or in the Y direction. And I have essentially 2 degrees of freedom. And we can continue this idea as a 3-dimensional object to build this up, and we can think of this as a cube in space. So given any point inside this cube, I can move it in 3 different directions. And so building on this idea here, we have a definition of dimension as something where it's the number of degrees of freedom for a point, freedom, that moves on an object. We can think of this as an independent parameter, or we can think of this as how many independent parameters we need to describe where it lives in space. So for the line, we need 1 parameter to describe where it lives, either to the left or the right. For a square, we can just need 2 parameters, essentially an X and a Y coordinate. And so the idea of dimensions is important because we can take one dimension and we can build it up to another dimension. So if I think about a one-dimensional object, so I take a line and I can convert that to a 2-dimensional object by taking copies of that line and stacking them on top of each other. So these are a bunch of one-dimensional objects, and I can convert that into a 2-dimensional object. And so this becomes a full 2-dimensional object by stacking copies and copies of it together. And so if I take that 2-dimensional object, I can convert that into a 3-dimensional object by stacking copies and copies of the 2-dimensional plane together, much like slices in a box, right? If I take pieces of paper and I stack those pieces of paper together, I can form a ream of paper such that I can form like a cube. So I can take lines, edges, and I can stack it all together to make a sheet of paper, and I take those sheets of paper and stack it all together to make a rectangular solid of those pieces of paper. And we can continue this up with building to the 4th to 5th to 6th dimensions, although it's hard for us to visualize what a 4th-dimensional object looks like in our 3-dimensional land. So stay tuned for more videos on what a Hausdorff dimension is, where we kind of break the idea of integer valued dimensions, and we start to see where we can have partial valued dimensions in our definitions. So again, stay tuned, and We'll see a video shortly.